is abundance a problem?
How did a grandmother's hobby start a business?
What brought fashions into factories?
What's the newest use for plastics?
Industry on parade. Peabody Award winner for public service, produced on film each week by the National Association of Manufacturers.
At harvest time, a bumper crop of tomatoes starts on the road to the nation's dinner tables. Part of our abundant food supply, it's also part of a problem that's created whenever the supply of a specific commodity exceeds the normal demand. For a closer look at this problem, we follow the produce to the processing plant, which buys it from the farmer, converts it into a variety of products for industrial and consumer use, then moves it into distribution channels. That's the normal course. But here, warehouses full to overflowing show us something has gone wrong. Production has overtaken sales. Now the scene shifts to New York, where representatives of industries directly and indirectly affected meet to find a solution. At the offices of the Can Manufacturers Institute, they plan a campaign to inform the public that tomatoes are abundant and therefore a good buy, and to remind the public through creation of new recipes of the nutritional values and taste appeal to be found in tomatoes. This involves a test kitchen. Tomatoes, by the way, are simply an illustration. As you see this, other campaigns are in progress, promoting the particular commodities currently overabundant. But the techniques are much the same, involving dishes like this tomacaroni stew, star of the tomato story. Now the advertising agency goes to work, an artist sketching the outline of a television commercial that will carry the message to millions across the nation. A full line of promotional material is prepared, along with copies of the recipe for display near the product on grocery shelves. Then the campaign goes back for approval to the men and women who planned it. They come from many firms, from steel companies, for example, suppliers of tin plate like Jones and Laughlin, which contributed advertising in the tomato campaign. There's cooperation by different firms within the food industry too, by retailers and distributors, as well as can manufacturers and tomato processors. Even the makers of macaroni take part, setting up the displays in the stores because their product is among the ingredients. And the grocer cooperates by displaying these ingredients on adjacent shelves. As a result, the shopper is reminded of a good buy. At home, the family gets a new dish, and abundance is a benefit again, because industry's joint effort to promote orderly marketing has helped restore the balance between supply and demand.
Population experts tell us we'll number 220 millions by 1975, 60 millions more than now. These new Americans will need many things, and today's luxuries will be tomorrow's necessities. Machine development will make this dream a reality. In addition to goods of every description, Americans in 1975 will need more jobs to support an expanding population. Can we have wonderful and more efficient machines and jobs in increasing numbers at the same time? The history of industry says we can. The practice of industry says we will.
A living room in Fort Worth, Texas becomes the birthplace of a new business. It began when Andrea Stewart came home from school with a project that caught her grandmother's interest. Mrs. Augusta Stewart was intrigued by the ceramic work the girl had learned in class. And together they went on with the work at home, where their experiments finally led to a ceramic book rest. Mrs. Stewart decorated her book rest with ceramic roses and soon found it was attracting widespread admiration among her friends who asked for duplicates. That's when the grandmother asked herself a question. If they're so popular, why not produce and sell them in quantity? In search of advice on how to start such a venture, Mrs. Stewart took her problem and her sample to an association of Fort Worth businessmen. By this time, she had decided on non-breakable plastic as the most suitable material for mass production. But she needed to know whether there was a firm nearby equipped for the job and interested enough to help. The answer, she learned, was yes. Mrs. Stewart's next stop, the local plastic molding company where her prototype was studied by the expert who would make the production mold for an improved model. She had checked with an educator who told her the bookrest should be adjustable, and this feature was incorporated in the lightweight design soon being turned out at the factory. Powdered plastic is fed into hydraulic injection molding machines, which produce more bookrests in an hour than Mrs. Stewart could make in a week. Easily trimmed and smoothed, the parts are lightweight, yet strong enough to hold unabridged dictionaries, books weighing more than 30 pounds apiece. And the finished product is easily disassembled for packing into shipping boxes or luggage. The production problem was solved, and a visit to a department store shows that the determination of a grandmother soon solved the sales problem too, through a national distributor, Brodart Industries, who liked the bookrest well enough to market the product all across the country. Now in wide use, the bookrest offers new evidence that America still holds opportunity for anyone with ingenuity and a useful idea.
A new shift reports to work at a factory. A scene that's familiar yet changing rapidly, as a closer look at the men in the group will reveal. More and more, a survey by Men's Wear magazine reports, they're getting away from conventional types of working clothes, shifting to colorful sportswear. As a result of this trend in taste, designers are turning out new collections, including the clothing we see here, adapting the newest casual styles to the special requirements of industrial jobs. Let's go inside for a preview by workers at the Long Island City, New York plant of Waldees Clothing Factory Incorporated, which has developed a special group of work clothes utilizing the fastening devices it manufactures. All the garments are washable, made of sturdy materials, and designed to sell at low prices in a store's work clothes department. All slacks in the group have creases permanently stitched in. Worn outside the trousers at the waist, a Madras shirt is trimmed short for safety. As a special feature, the pocket is equipped with a retractable tab for the plant's identification badge. Some of the styles, like this extremely high-rise waistband, may seem surprising in a factory scene, but the designers insist each one is an accurate interpretation of workers' clothing preferences. They call the collar on this shirt a freedom neckline because it may be worn with the zipper closed or open with lapels turned back. And this ensemble features crisscross belt loops on slacks that are tapered in the Ivy League manner. Because more and more women are working in industry, the theory is that the men are becoming more conscious of appearance, that they're wearing to work the type of clothing they also can wear after they leave the plant. Taking their cue from the survey that shows the working man wants a better chance to express his individuality and to compare favorably with men in other occupations, designers develop coordinated slacks, shirts, and jackets, providing more color and more style for the highest paid, best dressed workers in the world.
We Americans are always trying to find better ways of doing things. Our forefathers, who pioneered and discovered new frontiers in this country, have been supplanted by the scientists and technicians in American industry's laboratories. Every day, every week, every year, someone is discovering a new product or improving an old one which will benefit all of us. Each year, industry spends more than $2.5 billion in research. that creates new jobs, more and better products, which help all of us to continually improve our standard of living.
Here's a plastic which, when rubbed, develops static electricity and amazing ability to cling. Just the thing for holiday decorations, these partners decided, and thus a new use was developed for a material already performing a variety of industrial jobs. Dow Chemical Styrofoam is very light. A 9-foot board weighs only a few pounds, and it's easily shaped with conventional power tools being used here to produce blocks of the size needed for home ornaments. One of the most striking of the many plastics so useful today, this one is made of polystyrene, which is processed from coal and oil, then expanded to 40 times its original volume. An electrically heated wire shaped in the form of a reindeer speeds the production of Christmas decorations at the Somerville, Massachusetts plant of Styroformics Incorporated. When the shape of the wire is changed, the same machine can be used to turn out snowflakes, trees, stars, and other decorating pieces. Here's a closer view of the process as a piece of plastic is pushed against the heated wire. The operation produces a silhouette that's several feet deep, literally a reindeer stick, long enough to yield dozens of ornaments with the help of just one more machine, which will slice off the individual pieces. A bandsaw is used to cut the pre-formed stick, and now the decorations are ready for packaging. Various shapes are combined for marketing in a holiday assortment, which will include a chemically treated cloth developed by the company especially to build up an extra big charge of static electricity in the plastic. When rubbed on such a cloth, the styrofoam will develop and store so much of this charge that it will cling almost indefinitely. The idea that's based on the static electricity phenomenon, once regarded as something of a production problem, now opens a new market for the material. It gives a place in the home to a versatile plastic long prized for its industrial uses. Since 1949, it has found wide application as a low-temperature insulating material, easily shaped to fit complicated situations. Now it turns out styrofoam is as helpful as a holder for solitaire as it is to industrial firms who find it makes ideal packaging for delicate electronic components. Again, one development creates others, leading to new business and wider employment.
And polishing proceed, much as in the case of non-converted rice. Only difference is these hulls have given up the good they contain. No mystery about why these people spent their time and money in developing this boon to mankind. They did it in the hope of making a profit, the same motive that produces most boons to mankind. To the American homemaker, though, whose family generally suffers from none of the diseases of malnutrition so common in certain other countries, the real boon is the way the processed rice cooks. She's all for serving up more vitamins and minerals, but especially so when the rice that contains them is so easy to prepare. A load of Mississippi clay is dumped into the storage bins of a new plant at Meridian. A few days from now, it will emerge from the plant in the form of sewer pipe. First, it's ground to a flour-like powder under steel-clad wheels here at the W.S. Dickey Clay Manufacturing Company. Mixed with water, the powdered clay is formed into large diameter pipe on this hydraulic press. That was steam, not dust. The press exerts a force of 600 pounds per square inch, forming the pipe, trimming off superfluous clay, and scoring the outside of the spigot, all in a matter of seconds. The formed pipe then moves on to a dryer, in which the moisture it contains will be driven off. After drying here for several days, the pipes are rolled out to one of a number of beehive kilns, so named because of their shape. In the kiln, the pipe will be exposed to really high temperatures, beyond 2,000 degrees Fahrenheit, for another 2 or 3 days. The pipe must be carefully stacked so it won't change shape during the firing, except of course for a predetermined amount of shrinkage. Now the entrance to the kiln is closed off and gas burners start pouring in the heat. Salt is introduced into the kiln to glaze the surface of the vitrifying pottery. Then this opening too will be sealed. Pipe of smaller diameters is handled in a somewhat different way, although the basic process is the same. From a pug mill, the clay feeds into a horizontal press that extrudes pipe automatically in a continuous line of production. Not only does this method lower costs, but the pipe turned out is stronger, straighter, rounder, and longer. And increased production made possible by machines like these actually means greater employment in the plant than there would be under some less modern method. Instead of going into a beehive kiln, the smaller pipe is sent through a long circular tunnel kiln. In it goes at the left and emerges on the right, 52 hours later, ready to be put in the ground. Meanwhile, the beehive kiln has been opened and its glazed and vitrified contents too are ready for the market. With our current boom in new building, we need all this pipe we can get.
Industry on Parade finds in a Seattle firm called Norco Metal Products Company a classic example of what a business organization must do to prosper and grow under our system of free competitive enterprise. Founded 16 years ago by one man with just $21 capital, the firm has grown steadily by plowing back whatever earnings were left after taxes into the plant and equipment needed to make Norco a versatile manufacturer of metal parts for the products turned out by other companies. Then, looking about for a consumer product of its own, it settled on Venetian Blinds and did quite well in this field. But the firm's star really began to rise at comet speed after it poured 3 years of research and development into an entirely new type of Venetian blind. After much costly trial and error, it managed to break away from the field with a Venetian blind that is vertical rather than horizontal. Along the top of each blind runs a bar from which are suspended a number of slot holders. When that bar is rotated on its axis, the slats will rotate on theirs. Now the slats are hung in place. They can be taken off just as easily for cleaning, although it's been found that hanging up and down as they do, the dust doesn't settle on them as readily. Now let's see what vertical blinds look like in a house. Closed completely, they block all light and assure complete privacy. Or they can be opened to admit any amount of light desired. Finally, the blinds can be drawn aside like drapes to get the full benefit of picture windows. That's the end of our story. But we're sure it's not the last you'll hear of a little company with very big ideas.
Along with similar factories in 20 other beet sugar producing states, they form an industry that's the most efficient in the world in terms of man-hours required to produce a given quantity of sugar. At the Utah-Idaho Sugar Company's plant in West Jordan, the process begins after the beets are shredded. The thin strips are treated with hot water which extracts a sweet juice containing about 12% sugar. There's further treatment of the juice with a slurry of lime and water in carbonators, through which carbon dioxide bubbles. Then in a series of filter presses like this, the impurities are drained off before the juice, by now much thicker, is pumped to the pan floor for further concentration by boiling under vacuum. About 1 pound of powdered sugar is injected into the liquor to start the crystallization, and the result is about 94% sugar at this point. There are constant tests of samples by the expert sugar master, who uses his knowledge to keep the juices moving from one step to another at just the right time. Should he make the slightest error, a whole batch might be ruined by hardening in the pan. Only when all conditions are exactly right does the sugar move to big centrifugal drums, which spin off more liquid at the rate of 1,100 revolutions per minute. The crystals that remain are washed with distilled water, and the sugar finally moves on to revolving granulators where hot gases will dry the finished product. A product which has been subjected to exacting laboratory tests all along the line to ensure strict quality control. These men work with a two-in-one crop, for the beet produces not only sugar for human consumption, but a variety of byproducts highly valued as livestock feed. Thus, the industry supports two important parts of the Western agricultural community, livestock feeding as well as sugar farming. From mechanized farms comes a crop. Modern factories turn into a variety of sugar products that put energy into America's diet as well as America's expanding economy.
At an American university, the scientists of the future listen to an expert lecture. But something is missing from the picture. There are not enough of these students. And there's a shortage of teachers, too, of men and women qualified to instruct enough additional young people to fill the gap between the number of scientifically trained graduates and the number of openings they're needed to fill. These are twin problems, receiving increasing attention from leaders of industry and education, determined to correct the situation. Profoundly concerned about the scientist shortage, Arthur D. Little Incorporated at Cambridge, Massachusetts, has come up with a new plan conceived by company president Raymond Stevens, who explains it here to two recently graduated teachers of high school science who will participate. The firm hires both of them. But one of the new employees goes to work in the local high school. And the other goes to work in the laboratories of the firm, a research and consulting company. This arrangement continues for 1 semester. After that, they switch, alternating back and forth over a period of 3 years. In this way, the plan helps the school get a science teacher needed to help fill the shortage in the classroom, and Arthur D. Little Incorporated gets a research worker. It's a program that helps boost teachers' salaries while improving the caliber of instruction and qualifying teachers for part-time work in industry. By alternating this job in industrial research with classroom teaching, Miss Callahan in her first year out of college will earn more, and the research job will help her become a better teacher. His semester of teaching over, Charles Battet replaces Miss Callahan at the research company, joining the large staff engaged there in solving problems for companies, many of which have no research departments of their own. In turn, Miss Callahan will go back to teaching. This is to be her permanent career, for the program's primary aim is to improve the quality of the teaching of science, a critical need as we move into our industrial future.
A successful businesswoman gathering the raw materials from which she has built a prosperous enterprise. In the North Woods around Frankfort, Michigan, Gwen Frostic sketches the beauty of the landscape she loves and reproduces it in picture form for customers who send orders to her combined shop and store from as far away as New Zealand and Venezuela. In pencil, Miss Frostic transfers her nature sketches to linoleum blocks, one block for each of the colors that will be combined to form the final print. The same hands which skillfully carved these outlines were crippled by polio when she was a child. Doctors told her she would never be able even to write. The business she operates today is testimony to the success of her determination to overcome the handicap. Each block is locked into place in the chase of a printing press, the framework that will carry it into contact with the paper. For each color, an additional press run is required. College trained in the art at graduate level, Miss Frostic first put her talent to work producing designs in metal. When the war brought a shortage of copper, she joined the tool and fixture designing staff at Willow Run. Later went into printing with the intention of making stationery from her linoleum blocks. But she soon found she was spending more time printing formal cards, invitations, and the like than the pictures she loved so much. And that's when Miss Frostic moved to Frankfurt, determined to concentrate on the greeting cards and note papers that give her the medium she finds so suitable for self-expression. Now she makes her dreams come true, spending part of each day helping fill the orders from customers around the world and devoting at least 1 hour each day to walks through the woods and dunes that line Lake Michigan shores. On these walks, she looks for new material to add to the variety of scenes and subjects she likes to share with others. There are so many orders now that a staff is employed to help Miss Frostic ship out the products of the little plant. Delicate impressions of scenes she finds within walking distance of her home and shop, reproduced by a woman whose talent and determination seem to prove success often can result from mixing business with pleasure.
Industry on Parade visits Skygo Farms in Fulton, Missouri, to see how a modern dairy uses new methods and machines in the production, processing, and packaging of quality milk at low cost. In an air-conditioned milking parlor, accurately measured feed is cranked out from the floor above. Temperature of the solution used to wash the cows in preparation for milking is controlled automatically. After preparation, the machines take over, feeding the milk into receiving jars that hold 38 pounds apiece. With this spotless equipment, 2 men can milk 50 cows an hour, a long step from the drudgery of days gone by. Now let's follow the milk as it flows through clear glass piping directly to the processing department. Here, milk is heated to 135 degrees, then homogenized, heated to 175 degrees, and finally cooled down to 40 for packaging. A control panel includes a graph that maintains a constant record of temperatures used in pasteurizing. Automatically, the milk is packaged in sanitary cartons at the end of a processing line 10 years in the planning. It's a complete dairy system that includes distribution too, so that owner Henry Danuser can be sure his grade A product is fresh as it reaches the consumer. From the insulated cold of the loading room, the cases go into delivery trucks containing 4-cylinder refrigeration units. In this particular operation, there's no door-to-door delivery. The dairy concentrates instead on distribution through local stores and a sales system based on the same principle of automatic operation featured at the plant. Attractive drive-up vending machines make the milk available 24 hours a day, 7 days a week, courteously and silently handing out change when required. From cow to carton, the milk she buys is untouched by outside air. A modern dairy uses techniques of industrial production and marketing to maintain premium quality while avoiding the need for a premium price.